Hi, everyone. Here's another video from the JMED Maths Clinic team. I'm here just to work through today. We're going to talk a little bit about Pythagoras' theorem. So we're going to solve problems using Pythagoras' theorem. Just so you know that the JMED Math Clinic is open to any student who's having difficulties in mathematics or just need some additional help. We're here, we run our sessions from 11 a.m. Eastern time at Jamaica time on Sundays. It's about 2.5 hours long, but it's really 2.5 hours of intense mathematics learning. We try to transmit our passion, our knowledge, and our understanding. We focus on skills, we focus on sharing how we approach mathematics so that students who are interested, they can see how we think as teachers of mathematics and then be able to apply that and see how they themselves can develop as effective mathematics learners. In the end, learning mathematics is not about solving the problems on the paper, but learning how to become a problem solver as you move throughout the world. So today's work is going to be on Pythagoras Theorem. Pythagoras Theorem is a powerful tool. And one of the things that you'll find about Pythagoras Theorem is that its application is one of the most applied tools in mathematiks. There are so many areas in math that applies Pythagoras Theorem that we use it without realizing that we're using it. So the history of it, there's a long history surrounding that. So please, just make sure that you are reading and watching those videos as well that talks about the real life application of Pythagoras Theorem, because that gives you some context about how Pythagoras Theorem can be of use to you as you move through your mathematics journey. So today's lesson, as I said, is going to be on Pythagoras Theorem. And I just wanted to give you that heads up so you know where we are with that. So Pythagoras Theorem. So the important piece is to realize that Pythagoras Theorem is focused on right-angled triangles, or RATs, R-A-T. I always want to call it a RAT because it helps us not only here, but also in other areas. And if you start seeing the right angle triangle as a special type of triangle, it allows you to give it its due, support, focus, so that when you're working on it, you go, oh, this is a RAT. So why is it a RAT? Because it's right angled triangle, RAT. Now, Pythagoras Theorem is a good example of why calling this a RAT will help you to remember when to apply it, because Pythagoras Theorem really only works on a right-angled triangle. And if you think about Pythagoras, the history is that there is a lot of stories around whether Pythagoras himself created the theorem. In fact, there's enough to say that he didn't, but he was a teacher, and so he shared this theorem. But there's a lot of people also said that because he had his name attached to it, he's more like someone who stole the theorem. If you think about a lot of people in many cultures would use the term rat as someone who is a bit suspicious and so on. So if you think of the right angle triangle as a rat, you could say Pythagoras Theorem is connected in some way. That's one way to think about it. So a right angle triangle has one angle measuring 90 degrees. So when you think of a right angle triangle, the first thing you need to know, you either need to see that written in the question, or you can prove it, or you can see this little rectangle, this square here as an indicator that it's a right angle. And if you don't see this, then you should never assume it, even if it looks that way. Information may prove it, or it may be stated clearly in the question that a particular angle is a right angle. Once there is a right angle in the triangle, it automatically becomes a RAT, a right-angled triangle. These angles will never be more than 90 because, remember, the total angles in a triangle is 180. So if this is 90, these two together cannot be more than 90. And so one of the things you'll find out when you look at a right angle triangle is that the side that's opposite actually has a name. It's called the hypotenuse. And because it faces the biggest angle, that side also is the longest side of the triangle. That might not be something that you use in your answers, but you use it to understand whether you're on the right track. For example, as a check, is my answer showing that this side would be the longest side? Those kind of things. So it's the longest side, and the other two sides together cannot be longer than the hypotenuse. So the only side on the right angle triangle that has a name is called the hypotenuse. And the way to locate it is just simply to find the right angle and then find that side that's directly across from it, that side, the one that's directly across from the right angle on the diagram. So the other sides they have no names. They're just sides. We don't need to call them anything else. They're just sides. So as long as you locate where the hypotenuse is, we will refer to the other two sides on the triangle as sides. And you'll understand why we do this, because it's important that we do not see them as anything special, just sides on the triangle without names. And so it helps us to understand other aspects of mathematics and trigonometry when we get into that. So for example, if we look at these diagrams, you have three diagrams here. And if we look at the first one here, the question is, which of these would be the hypotenuse? Which letter represents the hypotenuse? I'm gonna, at this point, you can pause the video and you can have a go and say, I think I know which one is the hypotenuse, and you can just write that down. So you can pause the video. Okay, thanks for having a go at that. I'll show you. So on the first one, this one, what you'll see is that this is the right angle, and this side would be the hypotenuse. So in this case, it's not B or C, it would be A. The side that's labeled A is the hypotenuse because it's directly across. Let's look at the other one. On this one, it's a side labeled B. So the letters do not indicate the location of the hypotenuse. It just, the hypotenuse is the side that's directly across from the right angle. Likewise, on this one, by now you'll get the drift. That is the hypotenuse again. And as you can see, different letters can represent the hypotenuse. It doesn't matter. What determines the position of the hypotenuse is its relationship with the right angle. So at all times, you need to realize that this is a relationship thing. So we're not here talking about this is the hypotenuse. It's the hypotenuse because it's opposite to the right angle. So that's something to bear in mind. Now, many times we go and we buy television, anything that has screens on it, we go and buy them and we say, we normally describe these things by saying, hey, you know, I want a 50-inch television or a 25-inch television, and my screen for my mobile phone is this, or the screen on my laptop is this. And most times you see these in the specifications for these devices. But many people don't know that really when we're talking about the size, we're really talking about the diagonal of the shape from here to here or from here to here. It's not these sides. A lot of people don't maybe realize this, but we are not, when we say a TV is 50-inch, this is the measurement that guides that specification, not this to this or this to this. So that would just create so many distortions. What guides televisions is that effectively television takes on some specific ratios with the sides, like 4:3 or 16:9 or something like that. You'll see those ratios. You will not see square televisions unless people are being creative. So normally when you go into a shop, it will have almost a shape like this. And so that distance from one corner to the top corner to the lower corner is actually what they're talking about when they say it's a 50-inch television. Very important to note. So this is actually the size of your TV, that measurement. So Pythagoras theorem helps us to find the lengths of sides on a right. It only works on the length of the sides. So if we know the right angle, we now know where the hypotenuse is. So the theorem goes like this. Pythagoras, in his writings, in his teachings, he said, it's the sum of the squares on the hypotenuse is equal to the squares on the other, the sum of the squares. So the square on the hypotenuse is equal to the sum of the square on the squares of the other two sides. In reality, he's just saying side squared plus side squared is the hypotenuse squared. So if we square the length of this side and square the length of this side and add them together, then it would be equal to the hypotenuse squared. It's a powerful theorem and its roots go way back beyond Pythagoras. But as I said, people say he's a rat, but that helps us to understand that Pythagoras theorem is applied to rats. The other part is that it only works with sides. It's a side, it finds sides. If you know two sides of a right angle triangle, you can use Pythagoras to find the third. So let's look at some. So here is it, hypotenuse squared is side squared plus side squared. It doesn't get any more complicated than that. As I said, if you have two lengths of any two sides of a right angle triangle, you can find the third side using Pythagoras's theorem. We just need to have the hypotenuse or any other side or two sides and then find the hypotenuse. That's all we need. It's always working on sides and it's going to be guided by the hypotenuse. You'll see. So let's have a look at example. It's a right angle triangle. We have two measurements, 7 and 5, and we have x. Now, because we know that this is a right angle triangle, we know that this side would be the hypotenuse, the side marked x. So in this case, we're given two sides are given. Need to find this third side. So we know that we have two sides of a right angle triangle given in terms of information, and we're asked to find the third side. So we know this is Pythagoras theorem. That's the thinking zone. Remember, when we go into thinking zone, what I'm showing you is how my brain processes that information and how you should process that information. You don't really have to write this down. On this side is your working, but here is the zone where we think about this. This is where we are creative. We're thinking about how do we approach this, and we're guiding that as we move through the problem. So when you're working through, get into the thinking zone, because you cannot do math without thinking. And when you think, it allows you to make better decisions. So I'm looking at the problem going, two sides are given, trying to find the third. Okay, Pythagoras. What is important here is that the missing side is the hypotenuse. Now, if the missing side is the hypotenuse, I know what to do. I'm trying to find the longest side. So when I look at the formula, I'm going to have to add. Yeah, that's the essential piece to bear in mind, because we're finding the hypotenuse. It's the longest side. We're going to have to add in order to get there. And the formula is stated with hypotenuse squared equal. So that's useful. So we state Pythagoras' theorem. Hypotenuse squared equals side square plus side square. As I said, I'm keeping it simple. It's just the sides. The order in which you do this does not matter. If you put 5 here or 7 here, it doesn't matter. If you put 7 here and 5 here, it wouldn't change anything, because we're just adding in the end. So substitute the known values. X squared is 7 squared plus 5 squared. Simplify, so we get x squared is 49 plus 25. Remember that 5 squared is 5 times 5, and 7 squared is 7 times 7. We keep simplifying because it's just straightforward to do that. And then because we have x squared, we go for the square root of 74. Now remember, even though x squared is equal to 74, it's possible that we could get a negative and a positive response to this, because there are two values that when you square them, you can get 74. But because we're finding the length of a side, we do not need to think about the negative square root, because it's a length, and a length cannot be negative, not in the real sense. So we find the square root, but we just focus on the positive square root. Now here, you could leave your answer. If required, that's okay. It depends. In some questions, it might say, give the exact value. This is an example of the exact value. If it says write your answer to a certain degree of accuracy, then you need to know how to do those degree of accuracy. In this case, I'm writing it to 2 decimal places, but it depends on the question. And here you could lose a mark or gain a mark if you are willing to read the question carefully. All right, but that's the answer, 8.60 centimeter. Let's look at another one. Here we have 8 centimeter, 5 centimeter, x centimeter. And let's have a look. Get in the thinking zone, Length of two sides are given, need to find the third. So we know it's Pythagoras. It's a right angle triangle, it's a rat, we know it's Pythagoras. So the difference here is that the missing side is not the hypotenuse. So remember, the decision that you're going to have to take is whether you're finding the hypotenuse or whether you're not finding the hypotenuse. If you simplify things like that, then there's only one thing you need to know, is how to find what to do when you're finding the hypotenuse, and then what to do when you're not finding the hypotenuse. So it kind of set it up like a computer program. Am I finding the hypotenuse? I'll add. If I'm not finding the hypotenuse, here's what I do. So we state the theorem, it doesn't change. Hypotenuse squared is side squared plus side squared. Substitute the values in, don't worry too much about this, you'll get there. Then we can rearrange, we can start to simplify. And then I need to find x squared by itself, so I can either move this 25 to that side, I can just rearrange. And so the next step would be x squared is 64, take 25. Now notice there's a takeaway here. And as I said, we're not finding the hypotenuse. So we know that we're gonna have to take away. Even if you're struggling with your algebra on this, you must take the bigger number, it must be the difference between the sides, because we're trying to find a positive side. And if you even make a mistake and put the order wrong, you should know this. So you should use this to help you to understand algebraic work. And so we get x squared is 39. Find square root, x is square root of 39, and we go for the desired answer. So that's how we do that. Remember, you can pause the video each time if you want to work them out and then go through this. This one, you can have a go. You can pause the video here, have a go at it. Okay, let's go. You can pick up the thinking zone. 2 sides are given. You need to find the third, so Pythagoras theorem. The missing side is not the hypotenuse. State Pythagoras theorem, hypotenuse squared is side squared plus side squared. Substitute known values. Even though it's decimals, it doesn't change the work. We carry on simplifying. And as we simplify, those numbers are coming straight from my calculator, not from my head. And we reorganize. And then we find the square root of this. So x squared is 89.67. As I said before, you can pause the video. You can use that to guide you and then work them out and then check to see if you're on the right track. And then you write your answer to the desired degree of accuracy. So just so you know, this is Pythagoras theorem in a nutshell. Please feel free to, as I said, work through them, stop the video, work through the questions, stop, pause, and then have a go again. So all the best to you. And I hope that that was a nice, clear example for you. There are some more complicated ones, and I'll maybe throw some in a part 2 of Pythagoras. But for now, this is where we are. So good luck. Hope you enjoy that, and bye-bye.